Welcome to another episode of Everyday Nuggets. Glass. It's something we use every day without giving it much thought. From the windows in our homes to the screens on our devices, glass is an integral part of modern life. But have you ever wondered how this transparent material is created from ordinary sand? The transformation of sand into glass is a fascinating journey of chemistry, heat, and human ingenuity that spans thousands of years of history. Sand is an unlikely starting point for creating something as smooth and transparent as glass. Still, it contains the primary ingredient needed: silica. Silica, or silicon dioxide, SiO2, makes up about 75% of ordinary glass. However, not just any sand will do. The best sand for glassmaking contains at least 99% silica and very little iron or chromium, which can give the glass unwanted colors. But silica alone isn't enough to make good glass. Other materials are needed to lower the melting point of silica, which is naturally very high at around 1,700 degrees Celsius, and to add specific properties to the final product. These additional ingredients include soda ash, sodium carbonate. Lowers the melting point to about 1,500 degrees Celsius, making the manufacturing process more energy efficient. Limestone, calcium carbonate. Add stability to the glass, preventing it from dissolving in water. Feldspar provides aluminum oxide, which improves the durability of the glass. Cullet, recycled glass that helps the raw materials melt at lower temperatures. The specific ratio of these ingredients varies depending on the type of glass being produced. For example, window glass typically contains about 73% silica, 13% sodium oxide, 9% calcium oxide, and small amounts of other materials. Before we dive into the modern manufacturing process, it's worth noting that glassmaking is one of humanity's oldest technologies. The first known glass objects date back to around 3,500 BCE in Mesopotamia and Egypt. These early glasses were primarily used for decorative beads and small vessels. The Romans later advanced glassmaking technology significantly, developing techniques for blowing glass to create hollow vessels around 50 BCE. This innovation allowed for the mass production of glass containers for the first time. For centuries, glassmaking was a carefully guarded secret, with techniques passed down through generations of artisans. It wasn't until the Industrial Revolution that glass production began to be mechanized, paving the way for the large-scale manufacturing processes we use today. So how does sand become glass? The transformation happens through a carefully controlled melting and cooling process. Let's break it down into steps. 1. Preparation of raw materials. The first step involves cleaning the sand to remove impurities. The sand is then mixed with the other ingredients in precise proportions. 2. Batch mixing. The raw materials are thoroughly mixed to create what's called a batch. This ensures that the components will melt evenly. 3. Melting. The batch is heated in a furnace to temperatures between 1,500 degrees Celsius and 1,600 degrees Celsius. At these extreme temperatures, the individual particles break down and form a homogeneous molten mass. This molten glass has a consistency similar to honey. 4. Refining. The molten glass contains small air bubbles that need to be removed. This is achieved by maintaining a high temperature, which enables the bubbles to rise to the surface and escape. 5. Homogenization. The glass is thoroughly mixed to ensure uniform composition and temperature throughout the melt. This is crucial for producing high-quality glass without variations in properties. The transformation from solid particles of sand and other minerals into a flowing, transparent liquid is genuinely remarkable. It demonstrates how dramatically materials can change when subjected to extreme conditions. In our previous section, we explored the basic process of transforming sand into glass. Now, let's examine one of the most fascinating aspects of glassmaking: the creation of different colors and the diverse applications that make glass a versatile material in our modern world. Glass in its purest form is transparent, but throughout history, artisans have developed sophisticated techniques to create vibrantly colored glass. The addition of metal oxides during the melting process is the key to this transformation. Different metal compounds produce distinctly different colors. For instance, when copper oxide is added to the molten glass mixture, it creates a beautiful turquoise blue color. Iron oxide, depending on its chemical state, can produce either green or brown hues. One of the most striking colors, ruby red glass, is achieved by adding gold chloride to the mixture, though in tiny quantities due to its cost. Cobalt oxide produces the deep blue glass that you might recognize from blue glass bottles. At the same time, manganese dioxide creates purple tones. For yellow and amber colors, compounds of sulfur, carbon, and iron are typically used. These color-producing additives are carefully measured and mixed with the molten glass to ensure consistency and quality. Have you ever wondered why some glass appears opaque rather than transparent? This effect is created by adding materials like tin oxide or phosphates to the glass mixture, causing light to scatter rather than pass through clearly. While the basic principles of glassmaking haven't changed dramatically over the centuries, the technology used to produce glass has evolved significantly. Today's glass production is highly automated and precise, allowing for consistent quality and specialized properties. Float glass, which we use for windows and many other applications, is made by floating molten glass on a bed of molten tin. This innovative technique, developed in the 1950s, creates glass with perfectly flat, parallel surfaces without the need for grinding and polishing. For containers like bottles and jars, manufacturers use a process called press and blow, or blow and blow. These methods involve either pressing the glass into a mold or using compressed air to shape it. The automation of these processes allows for the rapid production of identical items. Beyond the ordinary glass we encounter daily, specialized glass types have been developed for particular applications. Tempered glass, used in car windows and shower doors, undergoes a heating and rapid cooling process that makes it significantly stronger than regular glass. When broken, it shatters into small, relatively harmless pieces rather than dangerous shards. Laminated glass, commonly used in car windshields, consists of layers of glass with plastic interlayers. This construction prevents the glass from breaking into pieces upon impact, enhancing safety. Borosilicate glass, known by the brand name Pyrex, contains boron trioxide, which gives it remarkable heat resistance. This makes it perfect for laboratory equipment and cookware. Optical glass, used in lenses and prisms, is manufactured with extreme precision to ensure perfect clarity and specific light-bending properties. The production of optical glass involves additional refining steps to remove any impurities that might affect its performance. Glass production does require significant energy, but one of its greatest advantages is that it's 100% recyclable. Glass can be melted down and reformed repeatedly without losing quality, making it one of the most sustainable packaging materials. When you place glass in your recycling bin, it's sorted by color, crushed into small pieces called cullet, and then melted down to make new glass products. Using recycled glass in production actually requires less energy than starting with raw materials, as cullet melts at a lower temperature than the original raw materials. Have you considered the environmental impact of your choice of packaging? By choosing glass and ensuring it gets recycled, you're participating in a remarkably efficient cycle of material use. Thank you for watching Everyday Nuggets. and joining me on this exploration of how sand transforms into the versatile glass products that surround us. If you found this information valuable, please like this video and subscribe for more fascinating insights into the materials that shape our world. Stay curious